Hi everyone, it's Mrs. Griffin with the Unit 2 Lesson 5 video about the distance formula. Alright, so for the distance formula, we use this formula to find the length of a segment or the distance between 2 points. They're the same idea. The distance formula is lowercase d equals the square root of x2 minus x1 squared, or change in x squared, plus y2 minus y1 squared, or change in y squared. Okay, the distance formula comes from using Pythagorean theorem on a graph. Okay, so if you want to do that, you form a triangle where the distance between the 2 points is the hypotenuse, so it would be a right triangle, and then we use the Pythagorean theorem to find the length that way. So if we're going to use the distance formula, we're going to just substitute in, and this is fine as long as you remember it. And you're going to do the change in x squared plus the change in y squared underneath the radical. 12 minus 2 is 10. 7 plus 7 is 0. 10 squared is 100. 0 squared is 0. And then when you get to the last part, now that you have it down to one number under the square root symbol, you can take the square root to get your final answer. If you're going to do this on the graph, like in number 2, I have -4, -5, and 1, -2 graphed on graph paper. In order to find the distance between these 2 points here, you're basically forming a little right triangle by connecting the horizontal and vertical distances. And then all you have to do is count the units. So you can do it this way. This is 1, 2, 3, and this is 1, 2, 3, 4, 5. The reason this works and compares to the formula is because if this is -4, -5, and this is 1, -2, doing the change in x gets you 5, because 1 minus -4 is 5. Doing the change in y, -2 minus -5, gets you 3. So that's what we're doing there. And then all you have to do is the Pythagorean theorem. So you can do your a squared plus b squared equals c squared. And the length you're trying to find will usually be that hypotenuse because it's across from the right angle you just created, unless the points happen to be vertical or horizontal. So then you can just do 3 squared plus 5 squared equals c squared. And you'll get 34. And then when you go to do the square root, you'll just leave it as a radical because it doesn't simplify and they didn't tell us to round. So for number 3, you can choose to graph it or do the distance formula. Either way is fine. If you feel like graphing it, that's fine. If you don't, you're just going to use your formula this way. It's handy when it's already something you have graphed to just use the graph and do Pythag. Remember, when you're doing change, you're changing the minus negative to a plus. You're getting -4 squared. You're getting 6 squared. Don't forget that squaring a negative does get you a positive answer because there are parentheses you should be putting there. And you'll get radical 52. Now, when you're applying that to something like this, it's saying that we have a triangle. It's already graphed for us. The vertices are given. We're trying to show that it is an isosceles right triangle. Those are two different concepts. Isosceles means we're going to have 2 congruent sides. And right means that we're going to have perpendicular lines. So this is kind of a review concept. So for starters, doing the isosceles right triangle, we're going to look at our lengths. Now, for AB, for instance, if you want to create a little right triangle here, you'll see that this is 1 and this is 7. And you can do the square root of 1 squared plus 7 squared, or you can set it up as a squared plus b squared equals c squared. It's the same idea. And you will get your distance for AB that way. So the square root of 1 squared plus 7 squared becomes radical 50. So I kind of combine Pythag with my distance formula. And then when I go to do from C to B, This is 3 and 4, so I can already tell you that from C to B that's 5, because using my Pythag triple 3, 4, 5, that would have to be 5. And for AC, I have another 3, 4, 5. So that would also be 5. So now I know it's isosceles because two sides have the same length. So they are congruent. To do it's a right triangle, I can show perpendicular by doing the slope. So I'm going to do that separate. So I'm going to look here. It's very clearly BC and AC. That should make the right angle. You can tell by looking. So I can just show that the slope for BC, I just counted it before, is up 3 and right 5. That's up 3 and right 4. So that's 3/4. And the slope for CA is down 4 and right 3. So that's negative 4/3. And then I know that these are perpendicular from my slope. So review from the earlier from lesson 2. Since they have negative reciprocal slopes, therefore, remember those 3 little dots mean therefore, angle C is a 90-degree angle. So triangle ABC is a right triangle. Next one, we are trying to find the perimeter of the triangle. So I'm going to graph it. And I'll find the distance for each one, because perimeter does mean to add up all the distances. So you can use your Pythag or you can use your distance formula. To get from O to B, it's up 2, 3, 4 and right 3. So that means that OB has to be 5 because it's a 3, 4, 5 triple. To get from O to A, it's 1, 2, 3, 4, 5, and 2. So OA, you can do the square root of 5 squared plus 2 squared. And then for AB, it's over 2 and down 2. So you can do the square root of 2 squared plus 2 squared. And then to do perimeter, all you have to do is add them all up. Now because we're not told to round at all, and you can't add radicals that are not like radicals, we just leave it. Okay, and then finally for number 6, we're finding the perimeter again. So the horizontal lines, A to F, for example, you can count. That's only 3 units. So this one's 3 and this one's 3. You can tell that immediately. Now to get length A, I'm going to do my Pythagorean theorem. That's 2 and 1. Again, you can do A squared plus B squared equals C squared out that way. Or you can do like I was doing before, the distance from A to B is, and just do the square root all at once. And you'll get radical 5. When you go to try to do that for this one, you'll see this is also 2 and 1. And here we also have 2 and 1. And here we also have 2 and 1. So since it's going to be the same work for all of them, you know that all of these distances are going to be equal. So you'll know that the distance for BC is also radical 5. The distance for EF is also radical 5. And the distance for DE is also radical 5, since they all have the same size triangles that create them. So then for our final perimeter, we're going to add these 4 radical 5s together, as well as these 2 3s. So 3 plus 3 is 6, plus, and then we have 4 radical 5s, because there is a 1 in front of each one of those. And that is our perimeter. All right, see you in class.